Hi, everyone. Thanks a lot for having me. Today I'll be introducing SurrealDB to you and walking you through some of its features. So this talk is titled SurrealDB for Rustaceans. So you might want to know what is SurrealDB for some of you who may not be familiar with it. So it's a versatile general purpose database management system. Some would call it a multi-model database. It's got features that can grow with your use cases. Our goal is to design a database that you can start with from the word go when building like your maybe even a hobby project, but be able to scale it up as much as you want to go. So I'm going to show some of the features that it has. It's an ACID compliant database. It's like a new SQL version in the sense that we've got tables, documents, and graphs. So like some databases, document databases, or maybe relational databases, and some are graph databases. They are sort of special databases. But with SurrealDB and some other multi-model databases, we support various ways of modeling your data so that you'll be able to use it in a general purpose way. You can enter data by first defining a strict schema, which is schemaful, or you can just start checking in your data into the database, which is schemaless. With SurrealDB, you can also mix and match between the two. You can start with schemaless database and migrate. You can start with a schemaless table and migrate it to schemaful as you go on. You can even like start making some fields only strictly typed, but then leave others flexible. But as you go on, as you discover like your use case, you can start to make it more schemaful. It's versatile in the sense that you can run it in memory entirely. You can persist it to disk on a single node using something like CrocsDB or SpeedDB. We support a number of engines in the database, like storage engines. We can also run it in a distributed setup using TIKV. TIKV is a key value store built in Rust. By the way, SurrealDB is also built in Rust. So TIKV is a key value store, a distributed one, which is written in Rust. Or you can use FoundationDB if you like. You can also run it in your web browser or using in-memory or using IndexedDB. So IndexedDB would allow you to actually persist your data in the web browser. You can also embed it in your application or run it separately if you like. You can, if you decide to run it separately, then you would have to start a web server, sorry, a database server, and then you can connect to that database server via a WebSocket connection or an HTTP one. It runs on Linux, macOS, and Windows, but we also support some other systems, but these are the ones that are specifically documented for. When you go to the website, you'll see installation methods for each one of those. We have a query language called SurrealQL, which is very similar to structured query language, but it has got some bit of improvements. And to For example, we do not have joins. We use something called record IDs. We can sync data between systems using change feeds. You also have a feature to listen to changes in your data using what we call live queries. You can use custom functions to keep your queries dry. With SurrealQ itself, you can define functions that you'll be able to use in your queries, sort of like how you would define your functions in your language, or even you can use JavaScript as well. That's something we support. There are plenty of features on the website, so I'm not going to walk you through all of them. So let's talk about the architecture. So when a query comes in, the first thing we do, it runs through what you call an API layer, which is basically the Rust SDK. So the Rust SDK is the one that's going to forward your query to the database itself. In an embedded setup, that's what we would call the query layer, or we also call it a compute layer. Then the compute layer will then communicate with the storage layer to persist your data, and also to query data from the storage layer. Those are the storage engines that I mentioned earlier. They sit on the storage layer. Now, I'm going to dive a little bit deeper into the API layer because that's what you'll be interacting with most of the time when talking to the database. So our API layer is divided into what we call engines. The engines are a way of accessing your data that's in SurrealDB and also storing your data. So we group the engines into local and remote. Local engines are the ones that you'll be able to actually embed into your database. The local engines, things like RocksDB, and then we've got the remote engines, whereby you connect to a database from an external server that would be running. So we've got an in-memory engine, which doesn't persist data. It runs the database entirely in memory. So with all these engines, you'll be able to embed them or run them separately and then connect to them using the remote engines. We also have the RocksDB engine, as I mentioned earlier. The SpeedDB engine. SpeedDB is a rewrite of RocksDB. So it has the same API as RocksDB with some performance improvements. Also TIKV, as I mentioned earlier, which is a distributed key value store written in Rust. FoundationDB, which is also a distributed key value store. And IndexedDB, which will allow you to run your database in the web browser. The WebSocket engine allows you to connect to an externally running database server using a WebSocket connection. The HTTP engine allows you to connect using an HTTP connection. And then finally, we've got what we call an any engine, which allows you to connect to the database using any of the engines I mentioned above. You'll be able to change them at runtime. So say, for example, you've got your connection string in an environment variable. You can actually change from one engine to another using just the environment variable without needing to recompile your application. So you can scale from something like a single node RocksDB. Like say, for example, you start running your database using RocksDB. And as time goes on, you want to move on to a distributed cluster, like TIKV or Foundation DB, you can actually set up the cluster. And once the cluster is set up, you can export your data from your RocksDB instance, and then restart your application by just changing your environment variable to point to TIKV or Foundation DB, and then your database will be running on that, and then you can import your data, and you don't need to recompile your application for that. So let's get started with the Rust API. So to start, you need to add the SurrealDB crate. So we use cargo add for that. Before I move on, with cargo add, by default, the only enabled engine is the WebSocket engine, because we use cargo features to minimize dependencies. So by default, we only enable the WebSocket engine, so you'll be able to connect to a database that's running remotely, but you'll not be able to use the local engines. So you can't embed your database without enabling some of the features. And also, if an HTTP is disabled by default, just to minimize the dependency you need to pull in. So when you say cargo add SurrealDB, you see a list of features that you can enable. So you'll be able to enable or disable whichever features you need or may not need. We need, so our API is run on top of SEDE. Like we make extensive use of SEDE for serializing and deserializing data. So we did not want to come up with our own macro for managing data serialization, deserialization. So instead, we've got SEDE, which is widely used in the Rust community. So we decided to reuse that. We also use Tokyo for our async runtime. So you'll be able to add Tokyo. If you use something like async standard, for example, it is a feature to support Tokyo. If you need that, we use Tokyo 1. So you can enable the async standard feature to support Tokyo. So you'll be able to run your SurrealDB database also on async standard. So how do you create a connection? This is the way you create an in-memory connection using what we call a static client. By static client, I mean this scheme, MEM in this case, MEM, is actually a Rust struct. So if it's not enabled, your program will not compile because you need to enable the cargo feature. In this case, it's called KV -mem that will enable the key value engine, the in-memory key value engine. And you are going to notice something very common amongst all these drivers, like all these engines. They all use exactly the same API, except for the scheme and except for the arguments to the new methods. For example, in this case, MEM doesn't need any path or endpoint to connect to. So we just use the Rust unit for that. But for the other engines, you'll be able to specify your endpoint so that you'll be able to connect. And also, if you've got, if you want to configure the connection itself, you can pass in a tuple with the endpoint at the first on the first index, and a configuration struct on the second index. So you'll be able to configure your connection however you see fit. So this is for the RocksDB. So a RocksDB is a file-based key value store. So it takes a path, is a path to your database. If the folder that you want your data to be stored in, or where you are already storing your data in. So it can be a relative path like this, or an absolute path. I'm using relative paths mostly in this presentation, because this way you'll be able to support other operating systems like Windows without if needing to change the path. But you can change it into a Windows path or Linux or Mac OS path. It will all work. SpeedDB is just like RocksDB, so it will take a similar path to where you'll be storing your data. TIKV, you put in an endpoint to your cluster. So you just set up, you first have to deploy your TIKV cluster separately. Then once your cluster is up and running, you can then point SurrealDB to that cluster using a URL like this one. For Foundation DB, this is the path to your cluster file. So it may be something in your etc folder, or wherever you have your cluster file installed. So you just point it there. And this is the WebSocket engine. As you can see, we've got the scheme WS, and then wherever the database is running it. And if you want to run using a TLS, you can use the WSS to connect securely. For HTTP, it's the same. So this is for plain HTTP connections without any encryption. If you want to use TLS, you can use HTTPS. So one thing you notice, like with these methods, when we are using HTTPS, the scheme is a parameter to the new method. It's not actually part of the connection string itself. It's not part of the endpoint. So now this is the any engine. With the any engine, you put the scheme inside the connection string itself, inside the endpoint. That's what allows you to run it even as an environment variable. If you like, you can just put all this in an environment variable, and then use Rust to query that environment variable and pass it into the any connect method. So you'll be able to change it at runtime, but you need to have all the features that you need to use for the any engine enabled in your cargo.toml, so that you'll be able to use them at runtime. Otherwise, you get an error message when you try to use them saying it's not enabled. So when connecting using like something like an any engine, in this case, we are, sorry, I skipped ahead. We haven't gotten to the any engine yet. So this is how you, like say you want to use a global connection, so that you don't need to pass it around. So you can just define it using SurrealInit here. So, and then in this case, we are using lazy, which comes from the one cell crate. So you can just initialize it globally, and then from main or from anywhere else you want to connect your database from, any other async function, you can then connect to your database. And this will work for any of the engines. File here is an alias for RocksDB. You can use that. It just, for now, it just points to RocksDB. So if you put RocksDB in here, it will be interchangeable. Nothing would be different. Now for the any engine, this is for the any engine now. So for the any engine, unlike the other compile time connections here that they use DB, so you're going to put in your your type is SurrealDB. But with the any engine, you put in SurrealAny. You are using the any engine. So if you go to docs.rs /SurrealDB, you'll be able to see the Rust documentation for the SurrealDB crate, and you'll be able to search for the full paths to these types. And like I mentioned earlier, for the connect method, you'll be able to see, you'll be able to put in your scheme as part of the endpoint here. So the first thing you need to do for the remote engines, before you start using a database, you need to sign in. With the local engines, by default, you are signed in as root, but you not be able to pass in your sign-in credentials by default when signed in as root like that, because to actually enable authentication with the local engines, you need to pass in your root credentials via the config struct that I mentioned earlier, which is the second argument to tuple on the new method. So if you do that, that will enable authentication, and from there on, you'll be able to authenticate just like you can with remote engines. So what you're going to see from now on. So in this case, we are connecting to a database. We're connecting as root with username root and password root. You can change that with the remote engines. When you start your database on the command line, you'll be able to start your database and then configure the root credentials that you will then subsequently use for when connecting with the remote engines. So this will work for the remote engines, but also if you enable authentication for the local engines to also work in exactly the same way. So the API is exactly the same, regardless of the engine you are using. So once you've authenticated, you need to select the database you want to use. So for that, you need to specify the namespace and database, because we support namespaces. Databases are in namespaces. So you have to specify the namespace in database. You'll notice with if you have seen our documentation, or if you are familiar with SurrealDB, the SurrealQL language is got a statement called use NS and use DB. This is the equivalent of that. So we've got some high-level methods that we use for manipulating data in database. So they are just abstractions of the queries. So, for example, you can create a data on a table. In this case, we are creating a person. This is a table called person, and you are creating a person with an ID called Toby. So we're creating Toby. We're passing the create. This is the create method. This is a high-level method in this case. So you can either pass in just the table, or you can pass in a table and an ID. So if you pass in a table and an ID like this, this is equivalent to what we call record IDs in SurrealDB. So this will create, when you pass in a single record ID, you get in return, you get an option because a record ID corresponds to a single record in the database. So in this case, we're going to create only a single person. So we're going to get an option. If you are creating a person with a random ID, you can just pass in a person without using a tuple. And then here you put in a fake because then by default, like all the methods, the CRUD methods when you are working on a table, they return a vector of things. But for the create methods, it's a bit tricky because the create methods currently will only return one item. So even if you pass in person, just person as a table name, you get a vector with one record. But we kept it that way for consistency with the other methods. And in future, we may change create to actually support creating multiple records at once as well. So here we are creating a person with these details. So the content method will allow you to pass in extra information for the table. So here we're creating a person with the title CEO, founder and CEO, and name with the name and first name. You'll be able to access this, like if you are using queries for something like this, you can access it much like you do in Rust. You can say name.first or name.last to get the first name or the last name. And here we're setting the marketing field to true. So everything in the Rust SDK or our API layer is async. So for all these methods, you need to await before you can actually execute the query and get results back. And this is how you update. Now we are updating the same record we created earlier, Toby. We are updating it, setting it, the marketing field to false. Here, as you notice, I'm using the JSON macro from the JSON crate. This is just for convenience so that I don't have to create a struct with marketing field just for this. But you can do that if you like. Actually, I tend to go that route personally when building my applications, especially those I want to put in production, because then you get compile time checks. With just a JSON macro like this, say for example, you misspell marketing, then the compiler will not be able to catch that. So yeah, it's convenient, but at the same time, you sacrifice some compile time checks. Now select. If you select a single person like this, you're going to get a single record as well. So you're just going to get exactly the record we created earlier, which is the person Toby and their details. Now, in this case, now we are selecting all the people in the person table. So if you just pass in the table name, as you know, that's what I was alluding to earlier. You don't need to put in a tuple in this case. So you just put in the person or the table name as a string, and you get back a vector. If you incorrectly put, say, for example, an option here, it will not compare. So you're actually corrected by the compiler. In this case, it will be with all these methods, the compiler will be able to check at compile time whether you are returning the correct data as you specify here. So if you are putting in a table name, you get a vector of records. If you are putting in a record ID, you get an option. You also be able to for the record IDs, we've got another type also called record ID or thing in the Rust crate that you can actually put in there as well. You see it later on. Now we call these range queries. So here we are selecting a person. We are selecting people with the range from Jamie to Toby. All those with IDs that are following sorting that are sorted, starting with Jamie up to, but not including Toby. This is exactly how ranges work in Rust. So you can put any Rust range syntax in there, and it will just work. Or you can put in a tuple and put the lower bound and the upper bound using the Rust range bounds, and then you'll be able to get your data as well. So here now we've talked about the other CRUD methods. Now we're moving on to delete. So if you do this, you're going to delete all the people in your person table. So you get back the deleted people as a vector. And if you delete a single person, you get an option. So that way it safeguards your. Say, for example, if you wanted to delete a single person, and you put in an option here because you want to delete a single person, but for some reason you forgot to pass in the ID as well. So you just put in person. You will not be able to compile your program, so you can't delete your table data accidentally that way. Also, you can use ranges with the delete methods as well, just like you can with the select method. So in this case, we're selecting everyone up to Jamie, but not including Jamie. So we're going to delete everyone with an ID that's lower than Jamie when you're sorting them. In this case, we are selecting a single record. We're selecting Toby. Now, moving on to advanced queries. So sometimes you may have queries that you want to run that you cannot use the high-level methods for. So for that, you need to use the query method. So for the query method, you can define your query however you see fit, and then you pass in the query into the query method. So if you pass in some parameters in the query like this, in this case, we're creating a prepared query statement. So if you put in some parameters, in this case, we've got a parameter called name, then you need to pass in the bindings for it. So in this case, we are binding a name to John Doe. So we're creating a user with a name called John Doe. And so once you do this and run, you get results back. But the results, because we've got in this query, we could actually put in some multiple statements in the same query, separating them using semicolons. So just like you do in SQL. So if you do that with the query method, you can get multiple results for the different queries that you put in. So to get the specific results you are interested in, you need to use the tag method, and you pass in the index of the query. In this case, it's just one query, so the index is 0. So the 0 is corresponding to this query statement. There is a convenient method that you can use. Like in this case, we created a user with a field name. Say, for example, you want to get just the name of the person. In that case, when you've got a single query like this, you can just put in name here as a string, and it will get that name field for you to extract it and ignore the other fields like the ID, because every record in SurrealDB has got an ID, which is a record ID. So that's definitely going to be part of the payload that comes back. So if you want to ignore that, if you don't care about that, you can just put in name in there, and it gets just the name. And in that case, you don't need to put in user, because here name is a string. So you can put in a string here and you get the name. So that's it for the random features I have for you today. Here's a link to SurrealDB. You can go to surrealdb.com and you'll be able to see all the links there for X, for our GitHub repo, for all the other social media platforms like Discord, for example. And on GitHub, I'm Rushmore M, and on X, I'm Rushmore M as well. So yeah, that's it from me.
Thanks so much, Rushmore. I suspect we're going to have some questions. Does anyone have any questions right now? Just applause so far. So we had one question earlier on in the chat, which is where it was returning a vector of persons. I think it was when you did just the select with the person. Is it trying to get the record as a person, and then if the parsing fails, returns an error, or what's the mechanism there?
Okay, let me try to go back to this slide. Okay. Okay, so are we talking about this slide?
No, it was the when you're querying the database for a person.
Okay, when you're using the select method.
Yes, the one that returned a vector. Oh yeah, this one was also good. Yeah, but it was the one with vector that we were looking at. Was the question.
Okay, all right. So sorry, would you mind repeating the question?
So does it try to get the record as a type person, and then if that fails, just returns an error, or is there something else at play? Like, is it just loosely coupled that the type is person?
Oh yeah, sure.
Yeah.
So it tries to deserialize the record as the person type using SurrealDB.
Mm-hmm.
So if that fails, it returns an error, and part of the error actually tells you what the database actually retained. So if you try to deserialize something and it gives you an error, you can actually see what the response was, and you'll be able to then adjust your type to be able to match that, if you like. There's also we've got a way to say, for example, you do not care about the type. In this case, like person, you do not care actually what like the type in the database is. You can use you can return a value, say require value here, but then in here you put in resource, resource from, and then you put in the normal record ID that you are passing in there, and then it will that will automatically switch it to something like, I would say, dynamically typed. So you'll be able to use it that way. So that's actually, if you go to like our WASM library, that's what we do. You'll be able to see it like that if you are curious. And we've got some examples also in the documentation and on our in the API docs on docs.rs.
Yes, and I had a question as well. So on the vector example, which I think is the next one in your slides, yeah, is there a way of streaming instead of getting all the results as a vector up front? Can you stream the results in one by one from a select?
Okay, currently you cannot stream the results. We, as you noticed earlier, like one of the features I mentioned were live queries. So with live queries, you would be able to stream, but it will actually be listening for changes in data. So if you put, we haven't put in the API on Rust 1.0 yet. We're going to introduce it shortly. But my plan is to add like a method here, like you just say after selecting, and then you say .live, and then from there it will stream the results. But the stream will not end because it will keep on waiting for results, just like you do with RhythmDB change feeds, for example. So yeah, for now you cannot stream it, but you'll be able to stream it shortly using live queries.
But there's no plans to ever have like a cursor approach to not streaming live results. The only thing in the pipeline is for live updates, right?
Not really. I can't say never, because yes, because we right now the select method, we just select everything in the database. So yes, streaming is likely something you might want to do, or you might want to limit the data you want to query. Right now, currently, you can only do that using the query method. You'll be able to then specify your limits in your queries. If you've got a large table, I wouldn't recommend using select right now. You'd need to use a query method for that, so that you can limit your result set. But yeah, in future we may be able, we may actually add some methods to actually limit your data, or even make it a stream, like you said. Yes. So I'm not saying never. It's possible, probably in future. Yes. If you are interested in that, we would appreciate a feature request, if you don't mind. But if I remember, I'll also put it up.
Does anyone else have any questions for Rushmore, or just generally about SurrealDB?
Can you manage indexes manually, or is that automatic behind the scenes? I never understand multi genre databases. So for example, would you be expected to set up an index yourself?
Yes, you can. We've got a statement called define for defining various things like tables, namespaces. You can also use it to define your indexes. So by default, the only indexes we create by default for the IDs themselves. So when you query for a record ID, you are automatically using a query for that ID. But if you've got other fields that you need to be indexed, you can create an index for that, and you can also create unique indexes. So just like you do in traditional relational databases, you can also do that. Yes.
Thank you.
You're welcome.
I want to add, I've been reading a little bit about the Surreal QL languages. There's a lot more to it, like with graphs and things like that, which kind of goes over my head a little bit at the moment, because I'm not used to graph-based databases. I'm an old traditional SQL and document kind of guy, but I am quite interested. In fact, I'm thinking of using SurrealDB to actually drive my website.
Awesome. Yeah, you can use graph data in SurrealDB. We've got a statement called relate that you can use to actually manipulate your data is graphs.
Mm-hmm.
Yes. Yes, I believe all these features are just scratching the surface. We've got a lot of features that I didn't list because I was worried it would go way over time. But we've got a lot of features that you'll be able to see if you go to our website.
So what's the next big feature you guys are planning on coming up that we can get excited about?
Okay, some of the features are still being worked on internally, but what I can say right now, what I can promise is I think the next big feature you'll see, we've got, so right now we've got live queries. You can use them using the WebSocket protocol directly without using the API layer. But we are introducing an API on the API layer to actually work with live queries in a nicer way. So yes, that's coming very soon.
Oh, I do have another question. Any plans for supporting gRPC or Quick? Ready for the HTML3 or HTTP3, whatever it's called.
Yes. Right now, I don't think we have any plans to support gRPC anytime soon. I'm not sure about HTTP3. I'm not sure, but no, I can't put in any commitments.
Put you on the spot.
Yeah.
Thank you. I think that's all my questions.
Yes, and the other thing that we plan to add in future as well is GraphQL to be able to query your data using GraphQL as well. And there's also something that I'm very excited about called compile time SQL query. So if you go to SurrealDB, oh, sorry, it's supposed to put in a dash. Yeah, so this is something I haven't been working on this for 8 months now because to prioritize other things. But now that 1.0 is out, I'm going to go back to this as well. So what this does is it allows you to run your queries using a SQL macro. So the SQL macro like this, so you just say SQL and then you put in your query without any quotes, like not as a string. So this will actually compare this at compile time and create all the relevant Rust structs at compile time. So at runtime, you do not pass, like we do not do any query passing. You just have like all the types already just constructed. So it's like totally eliminates passing. So it becomes 0, which is which would actually improve your query performances quite a bit because there will be no passing. And also the nice thing about the API that I haven't mentioned before is that if you try to pass, if like the API, it passes the query on the client side, and if it fails, you get an error right away. You never send invalid queries to the server, so you can save a bit of traffic for your server by the invalid queries being rejected right on the client side. And when you send in a query that's already passed, like we send a query type to the database, whether it's embedded or it's running remotely. When you get the query type, we do not repass it. We just use it. We just use it like that. So yeah, I really like this feature because it's going to improve like our parser performance quite a lot.
I really like it too.
Thank you.
Just make sure you finish it. I'm real excited now.
I'll make sure. Thank you.
We've got another question in the chat from Michael saying, how well does it scale, sharding, etc.? What's the amount of data you can have in it?
Okay, so currently for scaling, you'd need to use distributed engines like TIKV and FoundationDB. So it will scale as much as those engines can, because right now the SurrealDB, the query layer that I mentioned earlier is a stateless layer. So it will just send the data. So those metrics would depend on the engine that you are using. And we're also working on our own engine called SurrealKV, which will have some extra features, like, for example, versioning your data. You'll be able to version to query previous versions of your data using like the SurrealKV. And it will be distributed as well. So that will be another option for the distributed setups. So from there, that's when you'll be able to talk about sharding in the SurrealKV once we have it.
Michael's too nervous to speak. He says awesome in the chat.
Thank you.
He joined us. He's listening in on his lunch break all the way from the US.
Oh, wow. Thank you so much.
Different, Michael.
All right. Okay.
Yeah, I'm not nervous to speak.
All right. Okay. My apologies.
Well, thank you so much, Rushmore. That was brilliant. Does anyone have any more questions? I think probably lots of people will have them after the fact, so you might get a flurry of emails of people asking you about it. I'll just quickly share screen in that case to show.
I will say that I've been excited about SurrealDB for quite a long time, and when Kiara mentioned that you were going to give it a talk, I was very excited, wasn't I?
You were extremely excited.
I was like, what a coup. I appreciate it. Thank you so much.
No, thank you for that. Thank you so much. Yeah.
We really appreciate you coming and doing a talk with us, and I think you will definitely be welcome back if there's a new big feature and you want to come share it. Maybe dig into a bit more of the details of how it works under the hood. Then yeah, we would definitely love it.
You can show off the macros when he finishes it.
Oh yeah, sure.
Definitely.